Okay, so we have to find I1, I2, and I3 for the following circuit. So let's start by writing down the nodes. So let's call this node V1 and call this node V2. Now, the problem with this circuit is this portion, because when we write the directions of current, so let's call this IA, for example. How would we represent IA? Will it be IA equals V1 minus V2 over 2 ohms? Well, no, because we have this to worry about. So we'll get to that in a moment. So let's write by drawing or writing directions of current. So let's call IA moving in this direction. I1 is already moving in that direction. Let's have IC moving in this direction. Let's have IB moving in this direction. And I2 and I3 are moving in their respective directions. Let's write the equation for node V1. So we see everything's leaving the node. So it'll be IA plus I1 plus IC plus IB equals 0. Okay, and let's write the equation for node V2. So it'll be IC plus IB as they're entering the node, and it's equal to I1 plus I3 as they're leaving the node. Now let's start by writing the equations for all of the I's. So IA, what do we see about IA? IA moves from a high potential, V1, to a low potential, which is a 24 volts, because it's also 24 volts here. So it goes from high to low. So V1 minus 24 all over 4 ohms. By the way, if this was flipped, so like the minus was here and the positive was here, then it would be minus 24 volts over here. But the positive is moving in, the positive is in this direction, so it's 24 volts up here. So that's the equation for IA. Now let's find the equation for IB. So IB, it goes from V1 to V2, so V1 minus V2, all over 1 ohm. Now, IC is the tricky part. So let's say that let's call this portion VB, okay? We don't know what VB is, but we'll find it later. So to represent IC, it'll be V1 minus VB all over 2 ohms, okay? Now let's find I2. So I2 will be V2 minus 0, so just V2 all over 8. And I3 will be V2 minus 0 all over 4. Now we have to find a way to plug in for this VB. So we see here the IC moves through this dependent voltage source and comes out of the positive terminal. So VB increases by 3 VO. Okay, so VB plus 3 VO will be equal to whatever comes out from the other end. So it's equal to V2. But now we have to deal with VO. What will VO be? Well, VO is actually V2, because notice that this is the ground voltage. This is the ground pretty much. So it's 0 volts down there. So when V2 moves from this resistor through this resistor and reaches the ground node, it equals to 0 volts. So that means it has to decrease by a certain value that gives us 0 volts. So when V2 enters this resistor VO, so it's V2 minus VO, because the voltage drops and it equals to 0 volts. So the only way for V2 to equal 0, if it's subtracting by VO, is if VO is also 0. If VO is also V2. So V2 minus VO equals 0. And that means V2 is equal to VO. So we'll plug that into here. So VO is V2. And then we can bring the 3V2 to the other side. So it'll be V2 minus 3V2, and that's minus 2V2. Now we can plug that into IC. So minus VB, well, what's minus VB? So let's times both sides by a minus. So a minus and a minus turns into positive. So minus VB is plus 2V2. So this is just plus 2V2. Now we have everything that we need to finally solve. So let's write the new equation for V1. So IA, that's V1 minus 24 over 4 plus I1, which is did we write the one for I1? No, we didn't. Okay, I don't think we didn't write the one for I1. So I1, that's V1 minus 0 over 2. So it's plus V1 over 2 plus IC, which is V1 plus 2 V2 over 2 plus IB, which is V1 minus V2, and this is equal to 0. Now let's simplify it. V1 over 4 plus V1 over 2 plus V1 over 2 plus V1. That gives us 2.25 V1. Then we have minus 24 over 4, which is just minus 6. And then we have 2 V2 over 2 minus V2, and 2 V2 over 2, that's just V2, and minus V2, that's just 0. So we have this equation, and let's bring the 6 to the other side. So this is equal to 6. Now we can already solve for V1. V1 will equal to 2.667 volts. Now let's do V2. The new equation for V2, so IC, that's V1 plus 2 V2 over 2 plus IB, which is V1 minus V2, and that's all equal to I1, which is V1 over 2, plus I3, which is V2 over 4. Now, hold on a minute. I made a mistake. This is supposed to be I2, not I1. Because, see, for V2, I2 is leaving with I3, okay? So it's actually V2 over 8. So V1 over 2 plus V1, that's just 1.5 V1. Then we have 2 V2 over 2 minus V2, which is 0 V2. And this is equal to 1 over 8 V2 plus 1 over 4 V2, which is 0.375 V2. Now we know what what V1 is. V1 is 2.667, and let's divide both sides by 0.375 to get V2. So now we can get V2. V2 will be equal to 10.667 volts. Okay? So now what do we have left? Now we have to find the I values, which is what we wanted at the start. So I1, I2, and I3. I1 is equal to V1 over 2, and V1, that's 2.667 over 2, which will give us 1.3335 amps. I2, that's V2 over 8, so that's 10.667 over 8, which is 1.33375 amps. And then finally, I3 is V2 over 4, so it's 10.667 over 4, and that's 2.66675 amps. And these are your final answer.